Differentiate each of the following with respect to x, simplifying your answer wherever possible. The square root of 2 plus 5x cubed, x squared times sine 3x, e to the 2x over x to the 4. By first writing y equals tan to the minus 1 of x, arc tan x, as x equals tan y, find dy dx in terms of x. So let's have a look at this then. Okay, I've written y equals for each of them, so we can just write dy dx. So a here, part 1 then, dy dx is equal to something to the half comes down, something to the 1 less, minus a half, multiplied by the something differentiated, which is 15x squared. And then put the something in, of course, it's the 2 plus 5x cubed. So that's equal to then, so it's 15x squared on top, over 2. Bring this down underneath, so you flip that to a plus half, don't you? 2 plus 5, x cubed, is power half. So that's part 1. Part 2, dy dx. So it's u. It's a product, so we use a product rule. Dv dx, sine of something goes to cos of something, multiplied by the something differentiated, which is 3, plus v sine 3x, times du dx, which is 2x. So this is equal to, there's an x common here, so we can take that outside the bracket, 3x cos 3x, plus 2 sine 3x. So x squared makes 3x squared, cos 3x, yeah, and the 2x sine 3x is fine as well. So that's part 2. E to the 2x over x to the 4 now, so part 3. So this is a quotient, so dy dx is equal to v, x to the 4, times du dx, e to the something goes to e to the something, multiplied by the something differentiated, minus u times dv dx, 4x cubed, all over v squared, isn't it? X to the 4 squared. X to the 4 power 2, so that's equal to then. So there's an x cubed common on top, there's a 2 common on top, and there's also an e to the 2x common. So 2x cubed, e to the 2x is common. That just leaves an x here, and here we've got 2x cubed, we've taken out the e to the 2x, so there's just another 2 with a minus, over power u times 4 times 2 is 8, so that's equal to then, 3 of the x's will cancel from what's underneath, so it's 2e to the 2x, x minus 2, over 3 of the x's cancel from x to the 8 to leave x to the 5. So there's part 3. Now we can look at x equals tan y and find dy dx. So part B, x equals tan of y. So differentiating, 1 equals tan goes to sec squared. So this goes to sec squared of something, multiplied by the something differentiated. So that tells us then that dy dx is equal to, move this down underneath the other side, 1 over sec squared y. Now trig ratios, sine squared plus cos squared equals 1. So if we divide by cos, we'll have tan squared, won't we? Plus 1 is equal to sec squared. So there's the identity. So we can replace this by dy dx is equal to then 1 over, and the sec squared can be replaced by tan squared y plus 1. And we can write this the other way around, 1 plus tan squared y will be just x squared, 1 over 1 plus x squared.